What's up guys, welcome back to another video. So I'm going to be talking about DevOps versus software engineer. It's kind of a hot topic, and also if you're in school or if you're not studying, then it's something that might confuse you. Because you know what, even if I'm working as a cloud DevOps software engineer. It did start make sense only until after like 6 months into it, and this DevOps position is pretty new in this industry, so I understand people get confused, even those industry people as well. So if you're just studying computer science or not even studying, then probably this is a little insider information about what is the difference and why and what. Alright, so I'm gonna talk about software engineering, which is really about practicing, designing, requirement gathering, and also testing and maintaining software. Software developer focuses on more about development of software, while software engineer might be a superset of software development. So, in a broader term, software engineer SW has a lot of stuff like development, right? Test or networking, app, also let's say infrastructure. So software engineer is kind of an umbrella term, overarching the term for programmer, software engineer, QA tester, sysadmin. So software engineer can do all of these stuff. And then dev might be focusing on software development, and QA might be focusing on quality assurance. And then network technician or network administrator would be focusing on just one of those. Maybe app developer, maybe native app developer for Android, iOS, or like Windows desktop, right? And then we have infrastructure. This could be like a Linux, or like server maintenance, whatnot, right? And then so this is a software engineer. So if you're a programmer, maybe you're here, maybe you're a web app, right? It's a subset of all entire software engineering scope. And if you're like a database, could be database as well here, but so basically this is software engineer. And where does this DevOps come in? So DevOps is really about connecting dots between these each thing. Like in dev does development, and then traditionally in previous like on-premise environment, dev creates artifact like .jar file, executable file, and then pass this on to QA, and then QA is gonna test the jar file, and then infrastructure like Linux or sysadmin is going to deploy jar file on a server, right? Maybe like Tomcat server is running to host website server, and then after that again QA test is done on the server side, and then blah blah blah. So basically a lot of like passing around a product or artifact once developer finish writing code. But these days it is kind of rare to host application or server on premise. meaning that the companies own their own infrastructures like servers, network, database, and network, and they host their own servers. These days, everybody is moving to cloud because cloud is elastic computing, which means it's scalable. So if you want more traffic coming in, like spike like that, this time, traditional on-premise cannot support this kind of a huge spike in traffic. So there's a cloud infrastructure as a service provider, public cloud services like AWS and Azure. They provide elastic computing, meaning like fluctuating, so it can handle sudden increase in traffic or decrease in traffic as well. So it can expand or shrink in terms about how much computing resources you want. So that's elastic and also scalable. So I just introduced the cloud infrastructure to traditional on-premise. That is one kind of aspect of it for DevOps, because DevOps these days deal with cloud DevOps. And then another kind of perspective that I wanted to introduce is this continuous flow of CI/CD pipeline. So these days, DevOps are almost always using some kind of cloud technologies, and when they're using cloud technologies to accommodate scalability or availability, security, they almost always deal with CI/CD pipeline. So there's a 3 V's called volume, velocity, and variety. So the data expands, the traffic is gonna be huge, and we need to increase the velocity with development, and also we need to increase the variety. We need to support variety of platforms or applications. So that's what 3V stand for: volume, velocity, and variety. And this is our end goal. We want to achieve this one. And to do this, we have, this is a kind of means to end. This is a means. This is end. And then cloud is just a means to end. And then this continuous flow, this is CI, and then this is CD. So you might study this in school, CI/CD. Maybe not, because this is really like a practical stuff that you learn as a software engineer, and it's kind of like a new concept and a culture, the way kind of a methodology, software development methodology. And so I want to talk about CI/CD. So CI is continuous integration, and then CD is continuous deployment. So before I kind of talked about here, they do development, and then from there deployment is done by sysadmin. Kind of like, we had the silos, so to speak. So everybody has their own roles, and it wasn't quite continuous. Like, you need to hand off some of the artifacts or deliverables to other departments, and it takes time, right? But CI/CD model here, we are trying to achieve everything in the pipeline. So CI/CD here is, development, test, auto build, right? And then after that, so we want to do this. We want to automate this CI/CD. Key to CI/CD is automation. Automation, autonomous, so that it's kind of like a belt conveyor. Once you put the box in a belt conveyor, it'll go to the next person, and it'll go to the next person. It's autonomous pipeline. So CI/CD pipeline should be automatable and autonomous. So once your dev creates a jar file, it should be automatically tested by CI server like Jenkins or TeamCity, and then it should be automatically built. So multiple people committing to a same code base, same repository. Every commits should be built by CI server. So it should be, backend server or TeamCity or Jenkins should be set up in a way that it'll pick up all the commits from GitHub or Bitbucket, SVN, and then it'll do build. And the build meaning like, Maven or like Gradle, or even old one is like Ant build. It is to build a project. In a case of like, let's say Java, you need to compile and then create a Java executable, convert a code into byte data. For C++, you also need to compile, but those things can be done here. And after that, what's gonna happen is you wanna pass this. Once auto build is successful, then you wanna pass this to deployment. What does deployment mean? It means like, deploying this real like Java or like application in real environment. And where's a real environment these days? It's cloud. So how do I deploy this application to cloud? So there is like orchestration tool like Kubernetes, OpenShift, or we have another one, orchestration. Let's say we could even do like an AWS serverless or ECS, Elastic Container Service. We want to deploy this automatically. How do we do that? We can. So we use our infrastructure as code. Infrastructure as code. So basically, we can configure like environment variables, parameters to the environment in a code. So we can version control this as a source code, and then we deploy this, and then we can test as well. And then after that, like a configuration is done, database, networking, network. All of these stuff should be deployable by infrastructure as code. Like Terraform is one of them too. Terraform. And then after that, you want to test application running in cloud environment. So you want to execute auto test triggered by this whole like pipeline. So this is a CI/CD and this is DevOps. DevOps involves making sure that CI server is running to pick up all the commits, and also do like a regression test, running unit tests before so CI server like Jenkins or TeamCity is going to be responsible for building projects. And building project, you run unit tests usually like a Gradle script. And then once all the unit tests pass, then maybe you can create a Docker image here. So from here, maybe build artifact might be Docker image. And then Docker image can contain Python script or just a command to executable Java file. Then create the Docker image, upload this Docker artifact so that it's portable. Anybody can. It's kind of like a GitHub. It's you can just grab artifact, which is a Docker container, from repo, and then CD side is gonna be triggered, and this guy is gonna go to Docker, like a Docker Hub or like a repo, image registry, and then pull the image and then execute the image or container. Like execute image meaning like setting up container and executing something inside in this environment. So environment needs to be set up, so that's why we have I know this is really hard to be, even for me, Kubernetes. So this is like an orchestration platform where you can have multiple containers for scalability, availability, whatnot. So this is all automated with infrastructure as code, as well as like this auto build thing can be implemented by Python script or Bash script, usually like a Groovy for Java. So we, like a DevOps, like a cloud DevOps, deal with CI/CD automation and infrastructure as code. So we need to deal with this, like basically this. This is a gist of CI/CD cloud DevOps. So we need to So we deal with kind of like in the development side as well. IOC, which is inversion of control or dependency injection. So for us to be able to unit test here, some environments need to be injectable. The code need to be easy to, the code needs to be testable so that we can test different environment. So for that, we need to think about kind of these dependency injection, IOC, inversion of control. Like Mockito is a good one for injecting dependencies. So you need to have like kind of software development background, unit test, and also auto build thing is a kind of Dockerizing it, microservice architecture. So microservice is another one. I know we are covering a lot of stuff. Microservice, Dockerizing it, and then we're gonna deal with load stuff. Basically, you need to understand Bash scripting or Python, right? And after that, on the CD side, you need to deal with infrastructure. What does infrastructure mean? You need to deal with like setting up a network. So network, right? So we have network here. For example, like let's say, for example, IP tables for firewall or routes, security, other stuff like load balancer, proxy. In a case of AWS, it could be like a VPC, virtual private cloud. A lot of networking in Linux, like low-level stuff. We also need to deal with, could be we are dealing with like serverless, API gateway, database as well, to just set up an environment so that application can run. And then after that, you can configure stuff using like Ansible, Terraform, Vagrant, those infrastructure as code, and then you run application in real environment and get feedback. Like if tests succeed or fail, you need to do that in a real environment. And then once it succeeds, you deploy that deployment strategy like blue-green release, meaning that once new release application succeeds, then switch traffic from green to blue or other way around. So you don't turn off, you don't shut down instances running previous apps until you verify new version of app succeed deployment. So that's that. So release strategy wise, it's easy with these orchestration tools because it's easy to spin up new instances. It's easy to spin up a new Docker container, and you can kill those containers easily. They are ephemeral. So that's that. CI/CD is really about having a big overview, architectural design, and also design and develop with. It's basically about start with ends in mind. So start with a final goal in mind. You need to think backward and then think about dependency injection, inversion of control. You need to think about microservice way about designing applications, because you want to be able to have application scale not just horizontally, meaning that you can scale horizontally by adding more instances, but also you want to add certain application services, not entire services, but just one of them because it's more elastic. So that's like a vertical scale, and there's like a 3 cube of a scale. So in cube, this is vertical, this is a horizontal, and this is vertical, and then this is depth. This is usually sharding or partitioning. So this is a 3 cube scale, validity, and so you get to touch on many aspects, and you're gonna become an all-round player, software engineer, and cloud DevOps is one of the hottest position in these days, because you see lots of technologies like AWS, Kubernetes, OpenShift, Azure, a lot of stuff, Google Cloud Platform, GCP. Because you know what, these days, not many companies are really building application on-premise, on their own company. They are depending on their own infrastructure on these public clouds or private clouds. So it's huge demand because of scalability. Why are we doing this? It comes back to this 3 V's I talked about. This is the end goal: velocity, volume, and variety. To do that, cloud is just a means to ends, and DevOps is just a practice, culture, the way, methodology to make it happen. Before, probably you've heard about Agile, right? Agile Development. Agile Development is like iterative development, kind of sprint planning, Scrum. Every 2 weeks you set short-term goals and achieve it. You test, develop, and get feedback from customers. It's Agile because you are close to customers as opposed to waterfall. Agile didn't think really about automation or autonomy in this pipeline. So with Agile, you have a .jar file, for example, and you produce a jar file, but you still pass that jar file from a dev to, let's see, infra guy or sysadmin to deploy .jar file on their own server. How fast is it to deploy jar file, right? How scalable is the infrastructure? No, because they are on-premise instances. How easy to duplicate real production environment with this kind of environment? It's not that easy because you need to not only have a jar file, also you need to have packages as well, dependencies. These are not bundled with the jar file. That's the same thing like Python libraries. You need to download them in a local server execution environment. So that's where the container and Docker comes in, to bundle them up in one image so that everything is inclusive, like contained, self-contained. So you can just have this image and run this everywhere. You don't need to download packages and dependencies in each computer. So container Dockerizing is really portable. It's much easier. It's much easier to deploy as well. It's much easier to test as well with a Blink Glue release strategy. So Agile didn't really think about those stuff. Like think about .jar file. How easy is it to deploy and then test, right? They need to set up their own, they need to spin up new virtual machines to test this jar file on a Tomcat server, right? They are not using cloud. Also, it's not scalable really with just Agile, because Agile didn't really focus on infrastructure either. So this is kind of like a kind of overview of DevOps versus software engineer. DevOps is definitely super hot these days in the past 3-4 years. New technologies like Kubernetes coming up. So virtual machines kind of going dead, and we are going cloud and also serverless, microservice architecture, containerization, Docker, and also serverless. Because if you go serverless, you don't even need to maintain these infrastructure like network, database, IP routes, database, because all handled by cloud usually. So that's why people are going to serverless and the cloud, microservice and Docker. But yeah, this is kind of a gist of it. This is horrible, this marker is not that good. Anyways, so hopefully you got something out of this one. I bet that a lot of confusions or ambiguity with this, but DevOps is essentially cloud DevOps software engineer with focus on this, with focus on cloud, with focus on automation, with focus on software development and then testing and also deployment. It's a really cool field right now. It's, you get to deal with architecture, software architectures, like a load balancer, proxy, and multiple instances running so that it's prepared to fail. Design for failure. You need to have a duplication so that some instances might go down in certain regions, right? Because of outage or natural disaster. In that case, you don't want website to go down. In that case, you want to have multiple data centers and servers distributed across multiple regions, so that maybe West Coast server data center go down. In that case, you have replicas in East Coast or Europe or Asia, so that website doesn't go down, so that business keeps running. That's about availability. Also, scalability wise, you need to spin up many more instances to scale horizontally. But horizontal scalability is not just one thing. There's also vertical scalability too. We talked about cube scalability, vertical, horizontal, and depth. So you don't need to, with a monolithic approach, you couldn't split services within the app because it's in one jar file, big jar file. Whereas a microservice application, you can have a smaller jar file or smaller container responsible for just one service. And maybe for shopping, like an e-commerce application, web application, maybe shopping service as opposed to, let's say, shipping service. Or there are many services involved in e-commerce, let's say, catalog to show products, shipping, or maybe banking service, a lot of service integrated within backend app. You might want to just scale up one service, maybe banking service. Maybe you need to deal with a lot of transactions per second, right? So you need to scale up that. You can do that by vertically. You can just scale up certain kind of containers, and you don't need to do that for others because there's some imbalance in some requirement, like some demands in certain services. So that's more efficient. So that's why it's much easier to scale with the smaller services, stuff like that. So yeah, I need to get a better pen and but hopefully, I wanted to kind of share with you guys my visual diagrams, because that's how I understand and maintain abstract concepts. I really learn and remember everything by visuals and diagrams, especially abstract thinking stuff. So this is my abstraction. Anyways, if you liked it or if you learned something, like this video, and if you have any questions, let me know in the comment section. So with that said, I will see you guys in the next video. Enjoy!